I'm going to demonstrate how to use starch agar. Starch agar is media that provides the starch as the source of carbon for the bacteria. But only a few bacteria can do this, only if they have the enzyme amylase. Amylase is an exoenzyme, so if it is secreted, we're going to be able to detect if the starch was broken down, because we're going to add, after incubation for 48 hours, iodine. Iodine will bind to starch if it's present, and if it's missing because it was broken down by the enzyme, it will not be able to bind to it. So the inoculation is really straightforward. You use a loop, you're going to use aseptic transfer, and let the loops turn orange all the way. Remember that you're supposed to let your loops cool off. So I'm going to pretend I waited 10 seconds. And we're going to aseptically transfer from the stock onto the surface of the starch agar. I'm going to tap my culture. I'm going to go ahead and open my plate, make a single line. And this is ready to be incubated at 37 degrees for 48 hours. Now, after 48 hours, we have to add a reagent that's going to make the hydrolysis, the breakdown of the starch by the enzyme amylase easier to see. And I have two different plates here. One has E. coli, the other one has Bacillus subtilis. The way we do this, very simple. We just take our reagent, iodine, that's in a dropper. To make the halo that should be present around the growth of the bacteria more obvious. Now, if there is some starch present, we're not going to be able to see that halo, because the molecules of iodine are going to bind to the starch, and it's just going to look dark. If there's starch missing, it's going to be a lighter color. I'm just rocking the plates. And what I want you to notice is the difference in color. The E. coli is close to black, it's a blue-black. And here you have just that orange color. That's because there's no starch left over for the iodine to bind to.